This conference will now be recorded.
Okay, thank you, Rihal, for that welcome, and welcome everyone that's on the call and everyone that joins later. My name is Kurt Hull, and I work for Climate Change Connection, a nonprofit charity in the city, and we focus on Manitoba. And I'm also a part of the Climate Reality Project Canada, and I'm going to talk a little bit more about both of those organizations as I go along, just mention them. But I have to give credit where credit's due, and some of the slides here come from the Climate Reality Project, so that's part of why I'm bringing them up right at the onset. But to get started here, I'm going to talk about myself and what brings me to do this work. I have been working with this young woman here. This is Susan, my colleague. She and I are Climate Change Connection, and I've been working for 14 years with Climate Change Connection, working on climate change education and solutions. And when it comes to education, it involves, presentations like this, and Susan focuses on schools and teachers. And I, excuse me, but we also have got our website. So you can go to our website for information about climate change from a Manitoba perspective. And that's what is unique about our website. It's got information about climate change, emissions, impacts, solutions, all with a Manitoba focus. And that's what makes our website unique. You can either type climatechangeconnection.org, or you can just type climatemd.ca, and you will have access to all the information that we've got on our website. And we've tried to make it accessible, and hopefully the information, it's all in bite-sized pieces throughout the website. So we have our website. And before I started working with Climate Change Connection, I was working in industry. I'm a professional engineer. I still am a practicing engineer. And I worked for some 25 years mostly in manufacturing. And this is me when I had hair back in the day. And when I'm an engineer specialized in digital electronics. And the company that I worked for 23 years designed and manufactured electronics for agricultural equipment, construction equipment, buses, and trucks. So virtually all of the things that you see in this photograph were designed and manufactured here in Winnipeg by our company. But the company that I worked for, I started work with them. There was 12 of us here in a little shop near the airport. And by the time I left 23 years later, we had over 1,000 employees. We had 4 factories in 3 countries, and we had offices and engineering offices in another 2 countries. So, and I was pretty senior. I was vice president for a while. So I have that experience, that reality of working in industry and working within an organization. But before that, I was a young man. And as a young man, I was able to do some traveling and experience different parts of the world and a little bit about some of the other cultures of the world. There's lots more to be seen, but I was able to sort of broaden my horizons through some travel and some adventures. This is me in the middle of the Sahara Desert. I spent about 5 months, a couple of friends of mine and I traveling around West Africa, and again, expanding my knowledge and understanding of things and having some adventures. But then I met a young woman after I got back. And shortly after that, I started a family. And these are my kids when they were much, much younger. But when they came along, they changed my focus away from myself to other people. And I was very much concerned about them and their well-being, whether they were fed and healthy and had friends and were getting an education, etc. But then in 2006, I went to the movies downtown Winnipeg, and I saw a movie that changed my life. I don't know if you've heard of this film. It's quite, it's getting quite about 14 years old now, almost 15. But when it came on the scene, it changed a lot of people's thinking. It raised awareness dramatically to the reality of climate change. And it coincided with some reorganization that happened in the company that I was with. And I got a chance to refocus on a new career, because I really was sort of done with, 23 years working in manufacturing was enough for me. But within 8 months of seeing this movie, I was working full-time on climate change. And a couple of years after that, in 2010, I was invited by former Vice President Al Gore to attend some training in Nashville. And I received training. His organization was then called the Climate Project, but it was the organization that was formed after that movie, An Inconvenient Truth, came out. It was his movie. He was sort of the star of the movie, and they took the profits from that movie and they used it to found the Climate Project, which was involved in training people to give basically the presentation that he would give if he could travel all over the world and be everywhere all at once, all at the same time. And since then, I've been in I became a mentor, gave many presentations myself. And the most recent in-person training that I was at was in Minneapolis in 2019. And in each case, he led the training, and we've helped to train a number of climate leaders as a consequence of that. So now we've moved online, and there were two virtual trainings last summer. Along the way, I was able to meet him. I'm now on the board of Climate Reality Project Canada, and I've been able to meet Mr. Gore a few times. He's a very admirable fellow. He's a man of great integrity and knowledge in terms of science that he's learned and sharing it with us. But that concern that I showed you with my young family has been enhanced and has now been entrenched because of my concern for their future and for the future of my grandchildren. The photos, the two young girls in the center picture there are my granddaughters. And quite frankly, I am very concerned about the future that we are leaving for them. They are going to be facing some challenges that are not of their making, but we're going to talk about what that means. What is that, and where does it come from? The reality of climate change. Well, when I talk to people about climate change, usually the first reaction is, well, yeah, but isn't this just natural? Like, what's different here? Okay, let's look at that. Well, if you were to take and look back in time at the global average annual temperature of the whole globe over the whole year and plot it, this is what it would look like, okay? Scientists are very clever. Obviously, there weren't humans around with thermometers back then, but most of this information comes from ice cores in Antarctica. And by boring into the ice, they reveal ancient atmospheres. And by taking little thin slivers of the ice, they can do analysis and infer what the temperatures were. And basically what you can see here are, we go from ice age to warm period, ice age to warm period, ice age to warm period. So we go through, the climate has been going through cycles. Well, what's been driving those? It's obviously not humans. We haven't really had much to influence on anything for much more than, say, 20,000 years. So what's the driver here? Well, this fellow here, Milutin Milankovitch, he's a Serbian mathematician and astronomer who realized that there are certain recurring relationships and cycles in the relationship between the Earth and the Sun. And they're called the Milankovitch cycles. There's 3 primary Milankovitch cycles. The first of them is that the orbit of the Earth around the Sun goes from a circle to an ellipse and back to a circle over the course of around about 112,000 years. The second Milankovitch cycle is a change in the tilt of the axis of the Earth. The Earth goes around the Sun on a plane, and there's a tilt to the axis. The axis of the Earth gives us day and night, but then it goes around the Sun on once a year. That tilt, the day-night tilt, of the axis changes by about 2 degrees over the course of 41,000 years. And the third Milankovitch cycle is called the precession of the equinoxes, or the wobble. Okay, now because the Earth has got more land in the northern hemisphere than in the southern hemisphere, where we are in each of those cycles has a warming or a cooling effect. And sometimes those warming effects all pile up and we have a warm period like we're in right now, or they all pile up the other way and we have the cooling effects pile up and we have an ice age. So basically the difference between a warm period and an ice age is around about 4 to 5 degrees. Okay, so let's now, right now, we are in a warm period. We're already in a warm period and have been for a few thousand years. Let's take that and stretch it out. If we stretch out that last 2,000 years or so, if anything, the temperature was slightly cooling up until the Industrial Revolution. And then the color of the graph changes to green because that's coincidentally when we started to have a thermometer record. Prior to that, we have to have what they call proxy records with tree rings and ice cores, lake bottom cores, etc. But the green is indicating the temperature that we've been recording with the thermometer. Let's take that last couple of a year and 150 years or so and stretch that out, this portion right here. That's what it looks like. So in the last 150 years or so, the temperature has been increasing at a pretty, pretty clear trajectory. That it's been increasing over time. And the last few years, in fact, the last 6 years have been the warmest on this graph. The last 7 years are the warmest that you see in the instrument record. All of them, all 7 years are record years. Okay, so what's going on? Because there's obviously something different that's happened in the last 150 years. I used to be a quality manager. That was my thing. So charts and control systems, that was what I was doing. So there's obviously an assignable cause here. Well, what's going on? It's called the greenhouse effect. The sun sends its warming rays to Earth at a pretty constant rate. It does vary over something like a 22-year cycle, but it's cyclical, and the difference is only about 0.1% of its total emissions, and there's no trends that we can detect, okay? But the emissions that come to us, they warm the Earth, and there's also a re-radiation in balance with the absorption, and those two together, if there was no other changes happening, would reach an equilibrium. And if there wasn't an atmosphere around the Earth, the equilibrium would be reached, it's called a black body equilibrium, would be reached at about minus 18 degrees Celsius. But there's something else that's going on. It's called the greenhouse effect. And because of certain gases in the atmosphere, some of the infrared radiation is re-radiated back to the Earth. And so we get an additional warming that's happening. So because of the greenhouse effect, this is called the greenhouse effect, the average temperature of the planet before the Industrial Revolution was around plus 14 degrees Celsius, okay? So, but something has changed. With the Industrial Revolution, we've started to put more of those greenhouse gases into the atmosphere as we have been burning fossil fuel. Burning coal initially in the 1800s, and then a lot more and more, it's oil that we've been burning in the 20th century. And because of that, those emissions, and by the way, those emissions have been growing over time. This graph here shows how each year the emissions we've been putting into the atmosphere have grown to the point where in the last few years, we're putting something like 100 million tons a day into the atmosphere. And so what's happened is we've taken that envelope of atmosphere that we have, and we've been changing it. we've been taking that nice warm blanket that we've enjoyed, that's given us the ability to have civilization and culture and agriculture, and we've made it thicker, if you will. We've added greenhouse gases to that atmosphere, and in thereby doing, we're additional warming is happening. And we're seeing that besides those, those 6 record years that we've had in the last few years, we're seeing really hot temperatures in some parts of the world. We're seeing above 50 degrees Celsius in some parts of the world occasionally, happening more and more frequently in places like Pakistan and in the Arabian countries. We're getting 50 plus degrees happening with consequent effects on people's health, etc. And we're losing ice everywhere. We're losing ice in the Arctic, ice on Greenland, and in the Antarctic, really at a profound rate. And their scientists are now seeing an acceleration in the melting that's happening. And we're also seeing increases in the frequency and severity of hurricanes and the destruction that we see. I mean, you see that in the news every year. We're seeing more and more of this kind of thing. I'm not going to focus on that kind. Well, and then we've got droughts. This is in China. This photograph's from China. In different parts of the world, we've got floods and we've got droughts. And in other parts of the world, we're seeing, because of these increased occurrences of floods and droughts, we're seeing people with a disruption in their ability to grow food. And so that's what's happening, is we're getting climate refugees who are no longer able to stay where they were and are now having to leave their homeland and migrate to elsewhere. And because the world's so populated, they're not always welcome where they move to, and there are conflicts which are coming as a consequence. So that's sort of the global picture, the background, the causes of climate change, and some of the global impacts. But now for the rest of my presentation, or for the next part of my presentation, so I'm going to talk about local consequences for Manitoba. This photograph that you see here is of the rail line that goes to Churchill. The Manitoba goes a long ways north, and it extends into a region of permafrost. Permafrost means that the ground that's frozen last winter is still frozen in the summertime. If you scrape the ground away, you'll actually come to ice just a few centimeters below the surface. And when you put infrastructure on top of it, because it's melting, that infrastructure is becoming unstable. And another aspect of infrastructure in the north that's very important for especially First Nations communities and for other remote communities is the winter road system. There are a considerable number of communities in the province that don't have land access during the summertime. The only way they can get building supplies and quite a bit of their food supplies, tinned goods, etc., is by truck on a winter road that's built newly built every year. And what's been happening is that winter road is becoming less, the duration of it is becoming shorter, and it's less reliable. I'm working with a number of Northern First Nations right now, and we're trying to get a shipment of some supplies to build their sustainability, their food sovereignty. And the winter road is very likely going to come to an end at the end of next week. So that's what we're seeing. These communities are dependent on it for heating fuel. Ironically, they rely on diesel fuel to heat their buildings, keep them warm next winter. If they don't get diesel fuel this winter, they are going to be without next winter. So remains to be seen what's going to happen. Another consequence of climate change that a lot of people are aware of is severe weather. And as time goes on, we're seeing more severe weather happening more frequently with precipitation events that are happening. And here in Manitoba, we're no stranger to flooding, and especially springtime, spring runoff. This was a famous event from 2011 when we had a pretty significant spring flooding situation. In Brandon, they were fortunate enough to be able to protect themselves. This is 18th Street in Brandon, with the giant sandbags that they put up. They were able to protect themselves. A couple of weeks later, Minot, North Dakota was flooded. Their downtown was flooded, but the Assiniboine is connected to Brandon. The Assiniboine flows through Brandon and then through Portage-la-Prairie, or just south of Portage-la-Prairie. And just west of Portage-la-Prairie, there's a structure called the Portage Diversion. It was built a few decades ago, and it diverts a certain percentage of that flood water, northwards directly into Lake Manitoba. And in 2011, they opened it up as far as they could. It actually carried more than it was designed to carry, and flowed into Lake Manitoba. And then the way the water flows is it goes from Lake Manitoba, Lake St. Martin, and then into Lake Winnipeg. And the people who live on the banks of Lake St. Martin were flooded. They were literally given an hour or two to pack a bag and get out, and they were evacuated on an emergency situation, and many of them wound up in downtown Winnipeg. Many of them literally in the Marlborough Hotel. And it wasn't just that they were there for the weekend or for a week. They wound up staying there for months and in some cases years. The disruption to people's lives was profound. I could not imagine raising children in downtown Winnipeg in a hotel room. It's how a person could do that. These are climate refugees here in Manitoba. And it wasn't until 2016 that they were actually able to start moving back to their homeland. So that they were there for like 5 years displaced. Now, another thing is that when we have these flood events, the water that is flooding, it goes out over the land and it picks up everything. It picks up fertilizers from farmers' yards. It picks up manure from feedlots. It picks up diesel fuel. It picks up everything. And it all goes into the streams. It all goes into the rivers. And then it ultimately winds up in our lakes. And so a lot of what we're seeing in the eutrophication in Lake Winnipeg is because of the nutrients that have been added into the lake by flooding. There's other sources, but certainly a significant amount from overland flooding. Now, ironically, we also have to talk about drought. I mean, we've had a number of years in the last decade or so of more than normal precipitation, but we also experienced droughts here. I mean, we've had probably this last winter, we haven't had much snowfall. We could well have another drought coming. We're due. Around the turn of the millennium, we actually had a pretty severe drought, if you recall. And some estimations, especially further west, when you get into Alberta, it was one of the worst droughts in the last 100 years on the Canadian prairies. And here's a consequence of that not many people think about, is that when it's dry, it has a consequence for agriculture, but it also has a consequence for power. Most of our electricity comes from hydroelectric power, most of that from the Nelson River. And in the year of 2003-4, hydro had to import power from elsewhere, Saskatchewan and elsewhere, and they have to pay a premium for it. And as a result, they lost money. They lost almost $500 million that year. So when we have droughts, and we will again, hydro will pay, and we will pay as well. So there's that to think about. Now, of course, when things get dry, they burn. And another consequence of climate change and climate change drought is fire and forest fire. And anyone who lives in the boreal forest is subject to that risk. The most famous fire and the most expensive fire in Canadian history was the 2016 fire in Fort McMurray. And it has had a consequence, not just in terms of property loss, but also in terms of mental health. There's been an increase in addictions and mental trauma as a consequence of, you lose your home, you lose your job. It's pretty traumatic, probably family disruptions. And so that in Canada was the biggest. There's others happening more frequently and more severely in California. We're hearing about this more, like some of the videos that I've seen are literally like hell on earth. Like they can't believe what they have to go through sometimes to survive. to get away from it. And many people, unfortunately, perished in these fires. And here in Manitoba, a lot of folks live in the boreal forest, remote communities, and when a forest fire threatens, they're often having to be evacuated on a Hercules, like this picture here. Again, often on short notice. So that's the doom and gloom portion of my presentation. I've given it. Hopefully, you're still with me and you're able to still keep thinking ahead, because solutions are coming. Maybe not coming as quickly as we'd like to see, but they're out there and they're happening. All right, let's get into that now. Well, I think a really bright spot in this story happened in 2015. In December of 2015, the Paris Climate Accord was reached. In Paris, all of the countries of the world agreed that we have to get off of fossil fuels. The time frame is up for debate, and the amount of contribution from each country is sort of in a flux, put it that way. But the bright spot is that all the countries of the world agreed. At that time, Obama was president. He signed the accord. He was actually instrumental in getting the accord signed. There were two countries that didn't sign at that time, Nicaragua and Syria, because Syria had a civil war going on and Nicaragua didn't think that the accord went far enough. But in the months that followed, both Syria and Nicaragua have signed on. And now that President Biden is in the Oval Office, the United States is still part of the accord. So right now, all of the countries of the world are in the Paris Climate Agreement, in agreement to get off of fossil fuels. Well, that was in 2015. A year later, 2016, the Canadian government launched their Pan-Canadian Framework. And there are policies and funding that have come about as a consequence of this plan. We're starting to see things like funding for electric buses and other infrastructure coming from the federal government. So that was in 2016. And then about a year later, 2017, the Manitoba government came out with their climate and green plan. And so we've got 2015 globally, 2016 nationally, 2017 locally, and then in 2018, Winnipeg City Council adopted their climate action plan. So there are now plans. I don't really call them plans. In many cases, I just call them sort of discussion papers. A plan, in my case, in my estimation as an engineer, is a different thing, but they are at least discussion papers, intentions from all levels of government. But something else that I have to draw your attention to. Around Thanksgiving 2018, this document was released by the Intergovernmental Panel on Climate Change, the IPCC. And what they did was, in this document, was they looked at, first of all, what's the difference between 1.5 degrees of warming and 2 degrees of warming? And as I said, we've already warmed, like it was the temperature, average temperature of the Earth was about plus 14 degrees at the beginning of the Industrial Revolution. We're now at about we're about 15. We've added about 1 degree, 1.2 degrees of warming. And you can see it on this graph, one degree. So on the next slide, sorry, what you can see right there. So what this paper shows us is that we have been increasing the temperature. The global temperature has been increasing almost linearly for the last number of decades. And if we continue to do what we have been doing, it's going to continue in the same direction. What does it take to bend that curve? And that's where I call this presentation Bending the Climate Curve, just like bending the COVID curve, bending the climate curve. How do we bend this curve away from the straight line and make it flatten out, make it reach some kind of a stable temperature that would be consistent with the ability to function with a civilization? Well, this report quantifies it. It says if we want to be able to achieve something in this gray area here, like where we flatten it out, we need to reduce our emissions at a rate consistent with this graph. And what this is showing us is that we have to be reducing our emissions precipitously starting immediately. And by around 2030, our emissions should be about half what they are right now. We're in 2021, remember? So in 9 years, it should be half of what it was in 2020. And then by 2050 or thereabouts, we should be at zero emissions from human activity. Well, I hate to tell you, but we're not on the downward slope really yet. With COVID in 2020, there are some indications that our emissions may have fallen by between 7 and 9% are the estimates that I'm seeing. We won't really see the official numbers until probably 2022 or so. Yeah, we shouldn't see that until probably 2022, but there's a lag of 2 years. Anyway, but even with COVID, we've only seen a 7% reduction. What we need to achieve is that same reduction every year from now until 2050. Okay, just let that sink in. That we need to profoundly change how we do things. And there are some people that are pushing us in the right direction and away from our complacency, because up until now, our policymakers and our own individual actions have been pretty lackadaisical, put it that way. But this young woman here has changed things. Her name is Greta Thunberg. She's the young woman from Sweden who's really not taking anybody's shit. And she makes us all really stand up and take notice and not pussyfoot around with things. We have to take this seriously. And she's not afraid to speak at Davos. She how dare you, she said. But anyways, and we are starting to at least wake up. And here in Manitoba, I was really pleased to be part of a rally that we had in late 2019, where it was one of the biggest that I've ever seen at the legislature. The estimates are somewhere between 12 and 15,000 people attended to say, yeah, we're concerned about climate change. We really think that something needs to be done. So it's there in terms of awareness. And what are we going to do? Well, that brings me to the real solution portion of the presentation here. This is what I'm going to put forward to you, that I believe that we need to build our resilience. We need to be able to meet our basic needs ourselves without fossil fuels. Okay, so be able to meet our basic needs ourselves. What are our basic needs? Well, our basic needs are food, shelter, transportation. We need to be able to feed ourselves without fossil fuel fertilizers and without gasoline and diesel for the machinery, agricultural machinery. Shelter, we need to be able to heat all of our buildings, old and new, without natural gas. And transportation, we need to be able to move all goods and people without gasoline or diesel. I'll draw your attention to this Manitoba's Road to Resilience. Climate Change Connection is part of a group of NGOs called the Climate Action Team. And if you go to road to the number 2, road2resilience.ca, you will see our document. It's about a 50-page document which really lays out how it is that we can achieve those challenges that I was mentioning before. Those heating our buildings without natural gas, transportation, food and agriculture. How do we achieve a resilience in these 3 areas, and how do we use our electricity efficiently and effectively to meet those other 3 challenges? That's what this document does. We have a chapter on each of those 4, what we call technical chapters. And then in addition to the 4 technical chapters, we've got 3 foundational chapters. So as we move forward with those technical challenges and solutions, we have to ensure that we deal with the human impacts of climate change. There are generational injustice, there's cultural injustice, and there's economic injustice. The people who have contributed the least to climate change are often the people who are going to be or are already suffering the most from it. And so the young people like Greta Thunberg will be suffering for their entire lives with the consequences of the warming that's happening and is currently accelerating. We've got cultural differences. We've got people of color that tend to live in areas that are impoverished and close to pollution spewing factories, etc. We've got indigenous people living in remote areas and where the winter roads are in peril. We've got and that's all tied primarily to the economic disadvantages. We've got to ensure that our recovery from COVID is green, that we use it to address these issues and create new jobs that are not dependent on fossil fuels, and all the way along respect natural places and retain the carbon that exists in the boreal forest and elsewhere. So how are we going to do that? I'm just going to give you, for the next few slides, a thumbnail sketch of some, at least those three areas of food, shelter, and transportation. When it comes to food, we need to grow more of the food we put on the table ourselves, whether that's in your backyard or in this case, in a community garden. South Osborne, the folks there have done some really remarkable things in turning the grass near Churchill Drive into gardens and orchards, and working together to create more of their own food, which they share amongst themselves. We need to get closer to the producers, small farmers growing more table food with what's called customer supported agriculture, CSA. And there's a growing market here for customer supported agriculture. And this area here that I'm still learning about, called regenerative agriculture. I'm a vegetarian, but I've learned that if raised differently, I'm not talking about huge feedlots and corn mash for feed, but a different way of raising ruminants, they have a place to store more carbon in soil and soil health. So this is really quite exciting, actually, regenerative agriculture, and I'm learning from producers as to how this is done, and learning more about it. But it sort of speaks to the need to be conscious of nutrients and a nutrient cycle, and go back to a nutrient cycle and stop throwing good nutrients into the landfill, and instead get those nutrients going back into the food production system, whether that's in your household or in terms of agriculture, turning it back in. This is actually a operation in southeastern Manitoba, or industrially. So this composter that you see here is called an in-vessel composter. And if you go across the Assiniboine, go across the walking bridge, go back in to the west of the walking path, you'll come across this. This is at the Forks. The food scraps from the Forks are put into this vessel and are turned into compost. So that's food in very short terms. There's lots more to be discussed, but that's in general. Okay. When it comes to shelter and buildings, we have to address two aspects: envelope and a fuel switch. Okay. The envelope means we have to make our buildings more efficient. This house that you see here is in Sandy Hook. It's near Gimli. It's the first passive house, certified passive house in the province. It was designed by Bridgman Architecture, and it was built by Eric Bjornson and his company's Sundial Performance, and meaning that it was built to a standard that requires very little subsequent or supplementary heat. It gets a lot of its heat from those windows. Those are south-facing windows. And I know the owner of the building, and actually he sent me an email this morning. He was saying even at 30 below, he had to open the window a crack because it was getting, and he had to put new curtains and everything. So there's very little requirement of energy to keep this house toasty warm. And he finds it very comfortable otherwise, that because he has a ventilating system, positive HRV system. So with a a passive house, 1,500 square foot house, even on the coldest day, you can heat that house with the equivalent of a 4-slice toaster. So we need to make all of our buildings more efficient, energy efficient. And then heating, we do need to change the fuel, but we can't just switch to electric. Hydro cannot supply all of the electricity that is required in order to heat all of the buildings. If all the buildings that are currently heated with natural gas suddenly were heated electrically, we would have to more than double the amount of electrical generation we have capacity for right now. So let's keep that in mind. We have to make our buildings more efficient, and we have to make the heating as efficient as possible. And I'll talk about how we can do that. Okay, first of all, there's a way to preheat the air coming into the system. A solar wall. This is, see the black boxes here, they're actually open at the bottom, and the air coming into the heating system is preheated by the sunlight, and then as it goes up, it's warmer. It can actually add 15 or more degrees Celsius between the temperature at the bottom of that box and the temperature at the top. So that reduces the amount of energy required to keep it at room temperature inside the building. So solar walls. But then when we switch fuels, there are some applications for biomass, depending on where you are. Downtown Winnipeg, I suggest, is not really the best, but places like agricultural areas such as this one here, there's Providence College in Otterburn, southeastern Manitoba, and they heat most of their campus with straw and with the waste sawdust from a nearby furniture manufacturer. So that's what these hoppers are, and it heats. There's a boiler here. It boils water and glycol, and it's pumped in the pipes, and it heats in a district heating system. It heats the rest of the campus. And alternatively, if you are in a forested area, such as in northwestern Manitoba, I told you I work in northern Manitoba. I work in Northlands Denishis-Luna First Nation. And this operation here, I'm very pleased with it. We're taking and turning dead trees that have been killed by forest fire, into a major source of heat for the community. This white building in the background here is the heat plant, where the trees that have been harvested using local labor are in the same kind of a boiler system as in the Otterburn College, provide heat, and then the heat is used in the background. You can see this white peak, which is the school. So it heats the school, and it heats a cluster called the Lakeside Cluster nearby. All heated, or there's a district heating system to share that heat amongst buildings. So district heating is certainly an important aspect. And also geothermal. Here in Manitoba, we call it geothermal, but it's really ground sourced heat pump. We get the latent heat from the ground to preheat or to heat our buildings in the wintertime. And we also use the coolness, where we put heat back into the ground in the summertime, and it actually provides some air conditioning. We need much more extensive use of ground source heat pumps. And in a communities like Northlands, Lac Rocher, they also have lake-based geothermal, so water-based heat pump for providing additional heat for that system. And a less expensive approach, rather than ground sourced heat pump, is air source heat pump. I have an air source heat pump here. My house is heated electrically, and I can reduce the cost and the amount of energy required on many days by use of something that's called an air source heat pump. However, an air source heat pump is only, even the most efficient ones are only work to about -15. Below that, they still work, but it's no better than a resistive furnace. So this is what brings us to this idea of switching fuels. First of all, we need to stop expanding the natural gas distribution system. We are currently adding about 1% of the number of natural gas customers are increasing by about 1% every year. We have to stop that, stop making the problem worse, first and foremost. So just to recap, we can't just do a fuel switch. We've got to make our buildings more efficient, and we got to make the heating systems more efficient as well with things like geothermal. And another thing is we also have to add storage so that we have some in reserve. The most challenging night that we have to worry about in the future is that 30 below night in January, like we had a couple of weeks ago, because everybody's going to be wanting to heat their houses at the same time, and we have to be able to deliver quite a bit of power. And storage, some kind of storage is necessary in that system, whatever that looks like, whether it's batteries or chemicals or whatever. So transportation is the last section to talk about very briefly. And first of all, maybe we could do less traveling. With COVID, we're certainly learning how to travel virtually much more routinely, and with education and healthcare, etc. Active transportation, why take a vehicle when you could take a bike or walk? Why own a car? I don't own a car. I sold my car. Well, when my wife and I got together initially, we both had cars. Then we sold one, and we had one vehicle. And then in 2008, we sold the last vehicle we had, and we're happy members of the Peg City Car Co-op. And I only pay for the amount of time that I use it and the number of kilometers that I drive it. Save a lot of money. And then public transit. And public transit, we have to get out of our single passenger automobiles and make public transit much more attractive with a frequent service network. That's been debated right now this morning at City Council. And for vehicle transportation, the future is electric. There's no doubt. It makes economic sense at the passenger car level and at other vehicle types as well. Manitoba Electric Vehicle Association has been all over this for years. And part of that is the need for storage so that you can charge your vehicle with, we may well have a system where you don't, right now where you pay the same amount regardless of what time of day you're using the electricity. In other provinces, they have a variable rate depending, if you're using it during a high demand time of the day, you pay more for your power. And something like this, where you have a battery in your house, you can level that out. And so you can charge your battery when the power is cheap, and then charge your car at a time when it's expensive, if you need to. This curve is really, really profoundly important. The cost of producing a fossil fuel car with a 500-kilometer range is going up by the cost of inflation. But the cost of producing an electric car is falling exponentially. And those two curves are predicted to cross somewhere around 2023. When I started, this graph was put out in 2017, and some of the reports were saying that it could be as late as 2030, but since then it looks like it may be even sooner than 2023. At which point, let's think about the consequences to Alberta's product of choice, their tar sands, as a commodity that's attractive. When this happens, people are going to less and less want to buy fossil fuel cars. And so the product that is being exported, or they're trying to export more quickly with their pipelines, becomes less and less attractive to the market. The market is going to be moving away, and they already are from that. I could talk about that at length. So we've already got prototypes of the Tesla Semi. The only impediment here is them being able to get it into production. There's a massive demand for it. A number of different companies have already pre-ordered them. And who knows, cars may change dramatically in the future when we get to self-driving cars. And the Peg City Car Co-op that I'm a part of, right now the limitation of the number of cars is how close the customers are to the shared car. Right now the system is set so that you shouldn't have to walk more than about 300 meters to the nearest car share. And so therefore we're limited as to the number of members and the number of cars. When autonomous vehicles come online, you'll make your booking and the car will come to you without a driver. And then you'll use it, and then it'll go back to the next user, whatever. And so there will be no limitation as to the number of customers that a Peg City Car Co-op system can have. And it's not just cars, and it's not just trucks, it's not just buses. It's also farm vehicles. They're experimenting with self-driving and electric farm vehicles. And then my last slide here is to do with that challenge that I showed you at the very beginning about winter roads, and an alternative to the winter road system, because there will be a year in the not too distant future when the winter road doesn't happen. And if we have a number of airships that are dirigibles, they're not quite lighter than air, they're slightly heavier than air, but they're powered. They could be used all year long to provide transportation during the summer up to remote winter road dependent communities. So that's my presentation. And I'm now very eager for questions and discussion about what I've just said. I'm going to try to turn off my presentation. There it is, it worked. Okay. So here I am, open for questions, discussion, rebuttal, whatever you like.